welcome to another video. In today's lesson we'll be learning about Newton's second law of motion. Now if you haven't learned about the first law, make sure that you take a look at the video that we shared regarding Newton's first law of motion. But if you are done with that part and you are ready to transition to Newton's second law of motion, so you've come to the right place, and let's get right to it.
Now in this current lesson we're going to examine Newton's second law of motion. Newton's second law of motion. The first law that we've talked about in the previous lesson, it revolves around an object being at rest or moving with a constant velocity due to having no forces acting on it or balanced forces that cancel each other out acting on it, not resulting in any change within the state. However, Newton's second law says that there is a relationship, there is a direct relationship between the force acting on an object and the mass and acceleration of that object. Which is represented with the following formula: F equals to m multiplied by a, where F stands for the force, m for the mass, and a stands for the acceleration. So if you have an object, if you're going to apply a force on this object, you want to move a block, you want to move a ball, you want to move a sphere, you want to move a table, it depends on the mass of the object in front of you and the rate of change of the velocity or speed, which is the acceleration. So let's establish the unit of measurements for the force, which is newtons, given by the letter N. The mass is going to be in kilograms, and acceleration in meters per second square. Keep in mind you have to keep the units consistent in order to get the right results when you're doing the calculation. So if I have the relationship in front of me, which is F equals to ma, this wraps up the concept of Newton's second law, where you have a direct relationship between the force, the mass, and the acceleration. And let's go through this with the demonstration by an example. If you have a box which weighs 20 kilograms, and I'm going to be pushing the box with 30 newtons. What would be the acceleration, which is the rate at which this object will start changing its velocity and moving forward? And this would be calculated using the formula F equals to ma. Now, during the physics problems, it applies to all of the lessons. Always write down what is known and what is the unknown, what is given, and what are you trying to find. So what's given to me is the mass, which is 20 kilograms, the force, which is 30 newtons, and what's missing is the acceleration. So the force that I have is 30, which equals to 20 multiplied by A, dividing by 20, both sides. The acceleration equals to 3 over 2, which equals to 1.5 meters per second square. So if you push this box with 30 newtons and the block or the box has a mass of 20 kilograms, it will move with an acceleration of 1.5 meters per second square. So you can see the relationship that you have here between these three components. You have the force, the mass, and the acceleration. If you have the force given to you and you have the acceleration given to you, you're able to calculate the mass of the object, which is subject to that force. If you have the mass of the object, if you have the acceleration of the object, you're able to calculate the force acting on that specific object. Let me give another example where we flip the cases. Let's say example number 2. You have the same box, let's say 20 kilograms. And the acceleration of the box to the right is 3 meters per second square in this direction. What is the force causing this motion. We're going to follow the same steps. Write down what's given to you. I have the acceleration, which is 3 meters per second square. The mass is 20 kilograms, and I'm trying to find the force. So in this case, I'm going to apply the formula straight ahead. F equals to ma, the force equals to the mass, which is 20, multiplied by the acceleration, which is 3, equals to 60 newtons. So if I apply a force of 60 newtons, my 20 kilogram block will be accelerating with 3 meters per second square. So this simply wraps up the concept of Newton's second law of motion, which states that there's a direct relationship between the force acting on an object, its mass, and its acceleration. So I'm going to write down an example for you. You can just simply go ahead and try to do it by yourself as a form of practice. If you have a sphere with a mass of 30 kilograms and the acceleration is 4 meters per second square, calculate the force acting on the sphere causing the above motion. Now try to solve this practice problem and apply the exact same steps that we have followed earlier and write down your answers. And this wraps up Newton's second law of motion.
Now I truly hope that you found the video beneficial. If you did, make sure that you subscribe to the channel because we provide really high premium quality content that will transform the way you have experienced physics, engineering, mathematics, personal finance. These are the core topics that we cover in this channel. If that sounds interesting to you, then by all means join the growing community and stay tuned for the latest updates. I'll see you in the next lesson.